Right, here we go with homework sheet number 9. First question is a BODMAS question. Now we know from the BODMAS that the first thing we need to look at is the multiplication here. So we're going to do this part first of all. So remember it's non-calculator, so I'll expect to see the sum. 0.47 times 7. Get that answer and then do 4.1, subtract your answer. Question 2 is removing brackets. So 2x minus 1 squared, remember that's 2x minus 1 times 2x minus 1. So go through your 2x times 2x, 2x times negative 1, negative 1 times 2x, negative 1 times negative 1. Get your answer. Now the second one, because we've got three things here, the first one I'm going to do is I'm just going to deal with the brackets. So I'm going to do x times x, x times negative 2, 5 times x, and 5 times negative 2. So that's going to give me so many x squared, so many x's, and a number at the end. Now I'm going to deal with the 3 at the front. So I'm now going to times that by 3, which is going to give me another answer. Then to finish the question off, once I've done all of that, I'm just going to take the first answer that I got, this thing here, second answer that I got here, and do a great big takeaway sum. So I end up with so many x squared, so many x's, and a number at the end. Okay, question 3, solve. So that means bring back the brackets by factorising. So x and x at the front, you work out what goes at the end, and then solve each little bracket to get x equals and x equals. Similarly with part B, don't forget there is a part B, then it's the same procedure. 4x squared minus 8x minus 5 is 0. I'm going to give a wee head up here that when you come to do the brackets, we're looking for 2x and 2x at the front. Question 4, just doing these in class just now, so we need to factorise this. So 2x on the outside, you can work out what goes on the inside, and then for part B, whatever your answer was for part A, and then factorise your x squared minus 16 into a pair of brackets. Two of the brackets should cancel out for your final answer. Now question 5, find the equation in a line. Now you should know that every straight line has the equation y equals mx plus c. Okay, the m is the gradient and the c is where it crosses the y-axis. Now looking at this picture here, we already know where it crosses the y-axis, because it crosses the y-axis here at 8. Therefore we already know that when it comes to writing down the formula, we're going to have y equals something times x plus 8. We know that already. The only thing we need to find is what is this number here before the x. Now because it's the gradient, then we need to get the gradient of this line. First thing I notice is it's sloping down the way, so it's going to be a negative answer. Then how do you work out the gradient? Well, we can either use the formula y2 minus y1 over x2 minus x1, or in this case, no need to do that, because we know the height of the triangle, we know the width of the triangle, and we can just use the gradient as the vertical over the horizontal. Get that answer, stick it in your formula here, and there's your straight line. Part B, we're told that the point negative 6a is actually on that line. So take your answer for part A, which was y equals something x plus 8, and then just plug in these values. So that's your x number, so that's going to go in here. That's your y number, so that's going to go in here. So you end up with a equaling, whatever your answer is, times negative 6, oops, my pen's not working, times negative 6, and then add on 8. And that'll tell you what the value of a is. Question 6, the bridge. Now this question here, I'm hoping that you'll remember that this is a Pythagoras question. It's just a Pythagoras question in disguise. So Pythagoras means we need to be working on right angle triangles. So I'm taking this little right angle triangle from the bridge and I'm going to fill some values in. We know that the slope inside is 3.25. We know that we're trying to find this side here. So if we're going to use Pythagoras, we must know what this one is on the right hand side. Now if the picture tells us that the radius is 3.5, so from the centre to the edge is 3.5, so from the centre here to the edge at the top, that is also 3.5. If I've already used 2 of that for the height of the bridge, then the little red part here is going to be 3.25 for the whole thing, subtract the 2. So the part of the triangle that you're trying to find is 1.25. Now you've got all this information, you can do your Pythagoras to work out what that missing side is. Remember, the question though wants the whole length of the bridge. So whatever you get your answer to be, you need to double it. Question 7. So I'm just going to take each triangle, write them separately, put the information on it we know. Height of this one is 6, length of it is 12, slope inside of this one's what we're trying to find, the length of it is 10. Okay, work out your linear scale factor and then go from there. You know how to do that. Question 8. Solve this equation. Now I've been a wee bit nasty to you because I'm asking you to remove brackets and everything first of all. So first thing I need you to do is remove those brackets. You'll get an answer. Then remove the second set of brackets. You'll get an answer. And then add them together. So you'll end up with so many x squareds plus so many x's plus something else equals 18. Now the only way you can solve that is if you get that 18 from that side over there. So you've got so many x squareds, so many x's, and something else is equal to 0. Once you've got it equal to 0, we can use the formula x equals negative b, yes it's one of these, plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, so there's a lot of work in that question. Lastly, question 9, nice wee simple one to finish. Calculate the shaded area. Doesn't tell you in the question, but that's what it is. Calculate the shaded area. You have a little formula which says the area of a sector is the angle at the centre divided by 360 times pi r squared. So simply plug these values into that formula. Job's done. And that's us, guys.